Hello? Hello? Good. All right, let's get started. Hey, everybody. My name is Alvin. I'm from FireEye. We're a security company. Who I am, I'm a DevOps engineer, and my role basically consists of being, like, I guess, the main Jenkins janitor, taking care of our Puppet configurations, Artifactory, a lot of our tool chains that I'll be mentioning in a second. I'm on Twitter as well as pretty active on the Jenkins IRC. You can reach me at that email address. Today's agenda will be first going over an overview of what we do in the GSI group at FireEye, what the Great Migration was, moving our 150 to 200 or so Freestyle jobs into pipelining, why pipeline, and also why Docker, examples of how we leverage shared libraries to help our users get a better experience, how we went about doing this, and the benefits for the future and our lessons learned. So an overview of the GSI group. We basically consist of three different components in FireEye. One is Mandiant Incident Response, which are the people that you call when you get hacked. There's also the FireEye iSight Intelligence, where people can subscribe to our intelligence feeds and get up-to-date information on whatever the newest attack vectors and Trojans and things like that are. And FireEye as a Service, which was the group that I was part of when I first submitted this talk. And what we basically do is we basically take care of monitoring your network, your FireEye sensors, as well as being an extension, or in some cases, a total replacement of your security operations. But really, I'm here to talk about our DevOps goals, which is basically making that feedback loop from all the people on the front lines, what they discover out there, and how we can close that loop getting back into our software quicker. So here are a couple things that we build. Node, Django, Go, pretty much a whole plethora of different languages. And Jenkins is a great platform for us to build on because it is basically programming language agnostic. It doesn't matter what you're writing in, as long as you have a way to build it on Linux, which is what our Jenkins node runs on. It doesn't matter. So how we build, all our code is stored in GitHub. We build using Docker. So we have a Dockerfile that is contained in the dev repository that will basically build out a container with all the dependencies that you need for your build. And then we mount the code in there. We build an RPM out of it. And then we ship that. We test using Docker as well. And we've also taken those Docker containers and orchestrated them using OpenShift to spin up ephemeral environments for our dev and QA teams, where they can go in and at a click of a button get their own instance of the portal, complete with like your portal, your database, all kinds of all the containers that you may need to spin up an actual portal. You have that right there at the click of a button. And we also leverage that capability to spin up ephemeral environments for our testing framework to basically test against. And that all runs through Jenkins. We deliver using Artifactory. That's our main repository where we store all our artifacts. And we're pretty much like 99% like CentOS shop. So we use Yum repository to basically store all those artifacts. Deployment consists of using Puppet for configuration management and making sure that things stay in the correct state on the box, as well as using Fabric and rundeck in some cases to go ahead and either run Puppet to basically take that change that we put into Hyra data and apply that to that node, or we just use Fabric or rundeck to just basically install that RPM back out onto the box. That's normally for our dev environment. One thing I'd like to mention, a lot of people sometimes get confused between like CD and continuous deployment, continuous delivery. We're not at the state where we're actually like things are getting out into prod automatically. We do have those manual gates there where you submit a pull request to update your version in Puppet, and there's a sysadmin there ready to like press the button and watch what happens in case something goes wrong. So what was the Great Migration, which is basically what my talk is about. So this was our scenario. We basically were tasked to consolidate data centers and migrate Jenkins off of a shared instance with many different other groups within FireEye. Our timeline was about 60 days, and we had about 150 to 200 freestyle jobs that we had to migrate. There was also a total of about 20 different build agents. So these are like, you know, there's a few apps that run on Debian that need to be built on Debian. There's like CentOS 6, 7, and previously, all these build agents were monolithic. So the reason why we have 20 different ones of these is because they all have different packages installed on all of them. And you basically send the job to the right one. And you can kind of understand how confusing that may be for somebody that just joined the team. How would they know which build agent actually has all the dependencies that they need to build whatever app they're working on? And then we also were tasked with upgrading from a 1.x instance to a 2.x instance. So elaborating on our legacy Jenkins jobs, Jenkins is primarily used to run tests and build RPMs, and that's how we deploy in our environment. With the legacy jobs, there was a job template in there that basically SCP'd your RPM into a dev repo, rebuilt the repo, and that's how that piece worked. And we'll go over kind of how that was made better. There were ad hoc GitHub triggers that were created. So every time somebody created a new repo or they created a new branch, they would have to go in and basically create that GitHub trigger so that every time they commit to it or open a pull request, it'll send a build. It'll send a webhook to Jenkins to run a build. And there was also no owner or subject matter expert for Jenkins. So it was very hard in our company to basically, you couldn't go to any one person or any one team and ask, oh, how can I do X, Y, and Z? So we wanted to alleviate all these issues. Some of our goals. One was to build some sort of standardized and consistent CI pipeline. Many of the jobs in the old instance were freestyle jobs that, you know, there were, take a new employee example again. You would go in and you may see like, you know, 5 different types of jobs in there, and then you may go to your manager and ask, oh, well, which one of these jobs are the right way to do it? And then as people are copying all of these, you can imagine how much tech that accumulates. We decided that the DevOps team that I'm a part of would be the Jenkins subject matter experts. So when people had issues, they could ping us on HipChat or email us, and we would be their point of contact for anything Jenkins related. Our goal was to make new app onboarding as easy as possible. So all the developers, I'm sure there are many developers out here, you were hired to write, you know, Ruby code, Python code, Go code. You weren't hired to create Jenkins jobs, and that's the least of your worries every day. So we wanted to make that as easy as possible for developers. Our Jenkins jobs were not tracked in Git, well, because they were just Freestyle jobs, so they were in some XML file on the Jenkins master. So we had no idea, like, we couldn't version it, we couldn't see when things changed unless we go in the GUI and we kind of look through the change log that way. And our last goal was to decouple as many tools out of Jenkins as possible to make the maintenance of our Jenkins master and our whole cluster of build agents easier to manage. So here are the 4 different migration strategies that we kind of came up with. The first one is basically that we could just copy the XML files from the Jenkins home into our new instance. And the level of effort for that would be pretty minimal. And we would still basically get the same functionality out on the other side. But the main problem with that is our build agents. How are we going to reproduce that? You can copy the jobs over, but if we have to move those agents and those VMs can't be moved over, those jobs may not work like right out of the box. Global changes are very hard to do. There's something called the configuration slicer that you guys may have heard of that basically goes in and does this like kind of widespread change on many different jobs. But not every field can be changed through the configuration slicer. And the other method would just be to get on the master and basically run a sed command across your config XML files for your jobs. Say like if you migrated a GitHub instance or something like that, you would go in and change those URLs that way. And that there's human error that could be involved in that. And the job configurations were not in SCM. So we wanted to make that change. When we create, there's also the second migration strategy is to create Freestyle job templates. And this is kind of like poor man's shared library for Freestyle jobs, which means that you create these job templates and you call multiple building blocks of Freestyle jobs in whatever job you're creating. And that would make global changes a lot easier. So you could have a step, you could have a job that kind of checks out from GitHub. And if you were to migrate that instance, you could just go into that job template, change that URL, and then every job that uses that template would get all the changes. It hides many of the configuration details away from our users, so we can use those templates and use them as building blocks, and they don't really have to know much about what they do, but there can be issues with that as well, where it would be very hard if their build failed. It's very hard to trace through all the different job templates that you're inheriting and walk through each of them and walk through each build of them to figure out where the problem came up. It makes Freestyle jobs dry, but global changes can break all builds if it is something like a checkout job template that everything uses. If you make a change in there, like if you accidentally like put in the wrong GitHub URL that's unreachable, that would basically break everybody's build. The third strategy is to convert Freestyle jobs into pipeline jobs. And this would require the most amount of effort. You're not really gaining much. You're kind of moving the problem rather than fixing the problem. And you're doing a lot of work in moving that problem. The advantages are you get job configurations in SCM. So you can see as the build process changes with your code, what happened, when you added this particular change in your Jenkins file, and how it interacted with your code. It required people to learn the pipeline syntax. There was a large job footprint, same as with all the Freestyle jobs if we were to just copy them over. And most of this would be just too complex for many of our users. Like I said, if developers don't want to go in to a UI and do it, they wouldn't want to figure out all the different pipeline DSL steps and read through and figure out how those things are pieced together. And the same problem with copying the Freestyle jobs. You're going to be subject to repetition and tech debt. And the last migration strategy is the one that we chose, which was to create a shared library of pipeline jobs and pipeline functions. And then we also create build wrappers around that to basically give our devs the freedom to use this instead of writing their raw pipeline code, as you may see like on Stack Overflow, where it's like 200 lines of pipeline DSL, and tracing through that is not easy. So why pipeline and share libraries? So we're going to go over a couple of different problems and our solutions to them. First thing is overhead with Freestyle jobs. So like I said, developers didn't like going in the GUI and creating these jobs. We wanted to fix that. Jobs were not dry. So that means that there were things that were copied around. There were things that were repeated. And we wanted to narrow down that configuration base for our Jenkins jobs. So our solution to this was to use a build wrapper. And this build wrapper basically is a closure that is read in to our Groovy script. And our devs basically go in and set these parameters, and they basically get a job out of it. I like to coin this as something called pipeline as a service, where users have, our DevOps team has created these pipelines that they can onboard and use. And all they have to do is just use the parameters, or they can just use the pipeline steps that we've created and build their own pipeline. And the overhead with Freestyle jobs included having to create those GitHub triggers, like I had said previously. So we decided to use something called the GitHub organization jobs. And this basically goes in and indexes every single branch of every repo in whatever organization you set this up for that has a Jenkins file in it. And we'll see how powerful this is in the demos later on. And then we also just need to configure one GitHub hook instead of multiple ones on each of the individual repos. Okay. So job configuration drift. It was hard for us to see who changed what and when and why. So we decided to use Jenkinsfiles and stick those in SCM along with the code. In Freestyle jobs, it was very difficult to visualize what was happening without the use of like some sort of visualization plugin. We couldn't visualize like either like the job configurations easily or the build steps. We would have to scroll through like hundreds of lines of console output just to see like where that error was. So by using pipeline, we get this nice, pretty stage view. And by using the stage block in the pipeline DSL, you basically get all these different building blocks of what is happening, how long it's in that stage, and whether or not that stage was successful. So it would just call out to you where your build has broken, and you could easily narrow down into it. And Blue Ocean is a better implementation of this that wasn't available when we first started. The next problem is that it was very difficult to make global changes to 200 different Freestyle jobs. So in order to fix that issue, in our build wrapper, we can just create a function, which I'll show you this in the demo as well. We could create a function and basically add that function into the build wrapper that all the jobs are being called with, and they get the same functionality. So in this example, you see that if we had a build wrapper that had a checkout step and a build step, if we decided that everything that ran on a Docker build node would have a Dockerfile in it, we would just call this, we would create this step called Dockerfile lint, and we could just inject this into the build wrapper. And there's an asterisk on there because this is kind of like a double-edged sword, right? So if you were to insert that in there and everybody is using that wrapper, it would break it for everyone. So that's something to be aware of. And the last thing was all the monolithic build servers. So many of these build servers were servers that people built either by hand. There was no configuration management on them. And many of these people had since left the company. So we had no idea like who even to ask. And it wouldn't be very feasible to just dump like your RPM list just to see like what packages were installed and try to reproduce that on another node. Yeah, so changes on if you were to install or update packages on a build node. So we'll use that same example of a new employee again. A new employee has a new job and he tries to run it on agent X. That agent has an outdated version of Ruby on it, but he's trying to build this Rails app. So if he were to go in and upgrade that package, that may affect all the other Ruby builds that were using that version of Ruby on that box. So our solution was to use Docker. And Docker is one of the main tools that everybody in the FAS organization has been very gung-ho about. It gives us the ability to give devs their own environments on their own laptops that they can spin up. And that workflow directly translates into Jenkins seamlessly without them having to send us a list of what packages you need, what version of CentOS you're running on, those kind of things. So on the developer's laptop, they may have a Docker Compose file, and that Docker Compose file may spin up like that portal and that database for that portal. And once they're done developing that, like if you guys went to Jesse's talk yesterday where he said people have asked him, how do you build Ruby in Jenkins? It's the same way that you would build it on your laptop, right? Jenkins is just the glue to do something. So these are some of the sample Docker files that we have. You can see on the left, that's a Docker file that we have for our Puppet syntax checking and linting. And you can see that we're installing Puppet, and we're installing the different gems and the packages that we need to do this linting task. And then on the right, it's a Python app. So those are the dependencies that we need for that particular Python app. And you can see how different these may be. And before, this would be like 2 different monolithic build servers. But now they can all run on our Docker build agents off the same platform with just 2 different Dockerfile configurations. So some of the other things that we explored was Jenkins Job Builder, which had relatively complex YAML structure for just getting a simple job built. And it was pretty verbose in that way. And there was no easy abstraction for our end users to create those jobs. So it wouldn't really benefit them to use this versus just going into the GUI and creating the Freestyle jobs. There's also the Job DSL plugin, which programmatically seeds and creates Jenkins jobs. And this is kind of like the predecessor to what Jenkins Pipeline and GitHub organizations can do for us now in Jenkins 2. And there was no logic between jobs that you could have, so you couldn't stick something like an input step there for user input to see if a build should be promoted from the dev repo to the prod repo. So our starting point was a new Jenkins 2.x instance. We had stable build nodes built with Puppet. So these were just plain CentOS 6 and 7 nodes that had Docker installed on them. And Docker gave us the ability to basically not install like anything else, just the things that we need, which is like the base OS and some of the configurations, like the Kerberos configurations for the sysadmins to get onto the box. But besides that, there was nothing on there besides Docker daemon. So before pipeline, so this is where I start showing you some things. So before pipeline, you would have like a freestyle job that would look like this, and you would kind of scroll through and figure out what is going on. And most jobs would be even longer than this. As you can see, like it's pretty confusing for somebody who's new to come in here and figure out what is going on. So this was not something that we wanted in the new instance, which is the plain freestyle jobs along with the filtering by the plain freestyle jobs along with filtering by the built-in like views that you can create in Jenkins. There's a phase 2 where people tried to make their freestyle jobs a little bit better with that the Jenkins job templates that I had talked about. But the problem with that is you would have something like this, where the job configuration is a little bit simpler, but you have no idea what's going on in these. So you would have to basically click through these if you had issues and see where your job was failing, which made it very difficult to debug. Oh, sorry. Like this. Yeah, so you would have like multiple builders and templates that you would inherit, and these would not be something easy that you could walk through. You would have to basically go into each of them and see where it was failing. All right. So this was kind of pipeline before pipeline, which is which I'm sure many of you guys are familiar with, where you have a bunch of freestyle jobs, you have fan in and fan outs, and there's upstream jobs that trigger downstream jobs and all kinds of different things. And this was not a very easy way to visualize. And pipeline was Pipeline was suggested from the Jenkins team to kind of replace this type of workflow. So the new world, we found this GitHub by Michael Neal, which basically he created before pipeline shared libraries was really a thing, to go in and create a wrapper and call that wrapper in your Jenkins file and abstract a lot of the steps in that wrapper away from your end user. This is our Jenkins pipeline workflow. We'll see how this kind of fits in a second. But instead of walking through the code, it's probably easier for you guys to kind of look at this and visualize it. The key points I wanted to point out were right here, that there are Docker images that are being created here. And that's where we're not using those build agents anymore. We've gotten rid of the monolithic servers problem there. And then we also have logic with these 3 colored lines here, where we've decided in this opinionated workflow. So this may not work for anybody outside of us, but we've said that all the jobs that are pull requests, they don't get to publish anything to any repo. All the jobs that are based off of a develop branch, and you can define that. Some people have that as a develop branch. Some people have that as like a dev branch, whatever it may be. It's just a parameter in our Jenkins file. All those get published to our dev Artifactory repo. And then if you're on a master or a release build, those also get published to the dev repo first, but then they also have the ability to be promoted from the dev repo to the prod repo. So I showed you this earlier. So what we did was we basically took something like this, a Jenkins file like this, a Dockerfile like this to build all your dependencies to get this. All right, so demo time. Okay, so in here, we have a Dockerfile, which doesn't really have anything in here, but I just wanted to highlight that this was something that is it's like a common practice for us to have Dockerfiles with dependencies. For this particular demo, there are no dependencies that I need. A Jenkins file, where we kind of define all the different parameters that we may need for our build. So as you can see, we have code in our standard library to our standard build is our build wrapper. And based on the logic in there, we take in parameters such as that machine parameter to put you would call the node block with config.machine to send it to a label with the label Docker on it. A dev branch to define your dev branch. Same thing for a release branch. What the artifact is that you're trying to publish. Most of the time that's just start.rpm. But in my case, I'm not really building an RPM. What the HTML pattern is, and this is for publishing HTML results. And you get those outputs on the Jenkins UI. What the dev and prod repos are. These are important because these are what are in Artifactory. Where are you pushing that star.txt to? For the dev repo, we're pushing to Jenkins World Demo Dev. And for the prod repo, we're pushing to Jenkins World Demo Prod. And we define the 3 different workflows and what the scripts are for them. So for pull requests, what we want to do with those pull requests, what we want to do with the development builds, and what we want to do with the release builds. So in here, you can see that my code. There's nothing in here besides just this is demo for Ram because I was showing him a demo earlier. And then if we look at each of these scripts, all it does is basically kind of simulates a build that you may have where you have, for this particular build, all it does is it cats the code into a file, and we echo a statement saying which branch it's coming from. And then we also do that for the HTML publishing that we're going to have. And that's the same for the PR script and the release script. So let's see if this works. Okay, so we've made a change here. push to my fork. Open a pull request right here. Oh, great. Resolve conflict. Okay, so in here we've merged, or we've opened a pull request with our code, and it has triggered a build. And most people they don't really want to go into Jenkins and look at the build if this check mark comes back, if their build and testing job is working properly. As you can see, we didn't have to create any GitHub hooks or anything like that in here. It automatically did this for us. And in here, you can see, there we go. So from the pull request, the HTML script ran fine, and we see that here. Okay. So say we want to, where's this? Let's open another one. That pull request was for the master branch, but I want to show you the workflow for how it differs from between the master branch and the develop branch when we do that merge into it. All right, so it's doing its thing again. Here. All right, so it has tested again, and it works fine. So we merge this into the develop branch. And the develop job gets kicked off. So this is all taken care of by the GitHub organizations. We configure that one webhook to catch everything, and we have everything just triggering. So down here, we can see that we have a deploy step in there that basically publishes our artifact, which is that star.txt match, to our Jenkins world demo dev file here. All right. If we just open this, there we go. Right, so we see that the dev script and the dev job work successfully. So how does this differ from our master build? So on master, if we just merge the same thing into master, we merge it into master, it kicks off this build. And there's this promote step here waiting for us. And that is what we've decided as the gate for somebody who is empowered, like a manager or somebody on the sysadmin team that is doing the deploy, to go ahead and promote this build to production. takes a second. Okay. All right, so it got promoted to the prod branch. As you can see in here, there's nothing in here. If I were to reload Artifactory, you can see that in here, there is a release.txt. If we download this, open this, you can see, right, this is from our release build. And all of these things came straight from the from that Jenkins file that I showed you. So how do we do this? One, our group is pretty well into drinking the DevOps Kool-Aid. So there are people that are on the dev teams that are interested in making the processes better. So this first thing was not something that was very difficult for us to do. Maybe different for your organization, but just finding somebody passionate about sitting down with you and talking to you about their workflow, how they do their builds, and how you can make their lives easier is the first step. And also, there's probably some sort of freestyle job for their build out there already. And if that's the case, you may not even have to ask them how to do it. You can just take that and translate that into pipeline code. Next is start pipelining their workflow in modular pieces. So that's what we did in our shared library. We built kind of these different pieces, like checking out the code, running some sort of build script, archiving some artifact, whether that is an HTML report, or in some cases, they're archiving some of their builds onto the master as well. Publishing those builds to Artifactory, promoting those artifacts out of the release and master builds, and also sending emails or sending out reports in the post-build step. And finally, once you've built these steps, you're about like 95% of the way there. If you have these steps, you can share that with the dev teams, and you can empower them to just call your functions that you've created for them, and they never have to go into the GUI to do Jenkins configuration again. Or you can just build a wrapper to call those functions for them. Like I said, our standard build is our opinionated workflow for how we want things to be pipelined. And most people have just taken that and passed in the parameters, and that has worked for them without them having to build the pieces together and tie all the pieces together themselves. And then take all those different modular functions and apply that to other teams. So how is this, what benefits does this have? We give the devs their time back. We get to standardize on our jobs and our workflows. We standardize on our build environments, and it makes the maintenance of it easier because our jobs are not in Jenkins anymore, they're in SCM. So if the Jenkins master goes down, our jobs don't go with it. And also the same thing with Docker. The Docker configuration and the build configuration of those agents are on Dockerfile in SCM. So if those Docker build agents go down, we just rebuild them, and you just build your Dockerfile again, and you have a container that contains all the build environment that you need. Most of these lessons learned, I'm running out of time, but most of these lessons learned are things that I've talked about already. The easiest thing would be to just leverage the snippet generator. That'll give you a snippet of pipeline code that you can copy into your shared libraries and parameterize and generalize those. And these are some of the benefits of it for our future. So if we were to migrate GitHub, we can change those URLs very easily. Upgrading to Puppet 5, we can enable that syntax check using that wrapper easily. If we were to consolidate Artifactory, we just change those dev and prod repo names in the Jenkins file. And if we were to go to declarative, we can take all those scripts that we have in vars and call those directly in declarative. So go forth and pipeline. That's it. Yeah.